So guys, we want to prove this statement for all x is an element of z. Okay, x is an integer which can either be positive or negative. So case number one, we are going to take x to be positive. Okay, so when we take x to be positive, the x and x is not equal to 0. Okay, so when we take x to be positive, if we take x to be positive, there we are going to say modulus of x plus 1 over x, we are going to move this 2 to that other side. Okay, so modulus of x plus 1 over x minus 2, we complete the square. If we complete the square, we'll reach this point, which is square root of x minus 1 over square root of x, okay, squared. So after doing this, I think we can agree that this is more than or equal to 0, because we are starting from x. We are taking x is positive. So we're supposed to say x is more than 0 here. I'm sorry about the conditions. Okay, but I'm sure the question was supposed to say x is positive. Okay, so after doing this, if we take x to be 1, because if we take x to be 1, okay, this will be 1 over 1 for positive 1 right there. So it will be 1 minus 1, which is 0, which satisfies this condition. We are saying is more than or equal to. So if 1 is negative, because of this square root sign, okay, if 1 becomes negative, this will become positive. Okay, and this also, if we take negative part of x, it will be negative 1 plus 1, which is 0. If we take the negative parts only, with the positive and negative part, let's say this is negative and this is positive, we take negative 1, because we'll be putting 1, negative 1, because of the square root. Okay, let's take the negative part of the square root. Okay, so it's negative 1 minus plus, because the positive, we take the positive part of this, so it's negative 1, okay, minus 1 minus positive 1, which is minus 2. By squaring it, it will be more than 0. I don't know if you understood what I'm trying to say. So therefore, x plus 1 over x will always be more than or equal to 2 for this first case. For the second case, let's take x to be less than 0. Then we say we, instead of writing x, let's put y is equal to negative x. We substitute for x. Okay, so y is an element of the positive real numbers. So after that, when we substitute for y in there, remember we moved the 2 to the other side, or to the left hand side. So after substituting for x there, we get something like this. If you factorize negative 1 from this, you will find negative 1 in brackets y plus 1 over y. But the negative part will be affected by the modulus, which means the negative part will disappear. So we will be left with y plus 1 over y minus 2. So I think we can safely say that since y, we have defined y previously to be positive real number, so we can safely agree that this y plus 1 over y, modulus of y plus 1 over y minus 2 will always be more than 0, taking it from case 1. Because if we reach here, this part of our solution will be the same as the part of our solution. This part of our solution will be the same as this part. Okay, so we can conclude that by case 1, by case 1 or in both cases, we have x plus 1 over x. The modulus of x plus 1 over x will be greater or equal to 2 for all x is more than 0.